The ATLAS collaboration comprises nearly 3,000 physicists from all over the world. They've been together for nearly 20 years now. How did it all start? Let's talk to my colleague Peter Jenni, who was the first spokesperson of ATLAS, to find out. It's been an exciting time now for ATLAS. In fact, at the end of last year, there was a tremendous amount of excitement and enthusiasm over at the control room. Can you tell me what was going on?
It was the first time that we actually saw collision events, and one had good reasons to be excited.
After more than 17 years that ATLAS officially exists, I think this is really a very great moment. We should all enjoy it, and now we can start working.
Yeah. When did ATLAS start?
Officially, you can say it was October 1992. That is when we submitted the letter of intent with an experiment called ATLAS, and which actually, if one looks at the correct options, resembles very much the detector we have now operational. But the dream of LHC goes even back further. I would say the real kickoff date was '84, with a big workshop in Lausanne. It was a CERN ECFA workshop on the LHC. It's the largest volume detector. In fact, it's about 45 meters long. It's like a cylinder, like a cylindrical box with the beams on the axis. They collide in the center. Why does it need to be so large? We are dealing with very complex events, also at high energy, which we have never done before in a laboratory.
So the ATLAS detector is a large cylinder, about 40 meters long, 25 meters in diameter. It has to be large in order to include all the different components that measure different types of particles. It also has to be large at very high energies to measure the particles with precision. So a very large and very complex detector.
Yes.
A very large and complex collaboration to go with it?
We are maybe almost 3,000 scientists now working on that, spanning all the globe, something like 172 institutions to be very precise. Many engineers, technicians, and not to forget administrative personnel had to work on it. So it's a huge community, the ATLAS team.
And are they all located here at CERN?
Not at all. That would not be practical. No. Most of the people are located in the different universities and laboratories around the globe.
Now, very soon, the LHC is going to provide collisions at a higher energy than we've ever had before. Is this going to change things? What's going to happen for ATLAS?
This will allow us to search really for completely new phenomena, new particles. There are other aspects. In fact, one of the main goals of the LHC is to find the famous Higgs boson. Or the point of the LHC, it will have not only higher energies, but also much higher intensities. Many more protons hitting each other. So the chance to see something very rare, of course, becomes then larger. We are really entering new territory with the LHC. And as an experimentalist, I think this is the most exciting part. There could be something not foreseen yet by theory.
So at the high energies of the LHC, ATLAS is now entering the frontiers of science. It could discover one of the particles that's been predicted, like the Higgs, or perhaps supersymmetry, or even more exciting, something that has never been predicted.